In this section, we're going to be looking at what are called parametric equations. Those are equations that involve a parameter. We're going to talk about what that is in just a minute. And then we'll show how the parameter helps us to see the orientation or the direction that the function is moving. So what is a parametric equation? If you look at the formal definition, f and g are continuous functions of t over some interval. Then f of t and g of t represent a parametric curve. So what does that really mean? Well, normally in algebra you have x, right? And you have y. And we would say that y is a function of x because you choose different values for x. And when you plug these values of x into the function, you get the output y, right? So this is like 2 times -1 plus 3, 2 times 0 plus 3. So you're plugging in x to find y. But in a parametric equation, both x and y are found by plugging in some value t. So first I choose the values of t. Then I can find x by plugging t into the equation that defines x. So this would be like 2 times -1 and 2 times 0 and 2 times 1. I can also plug t into the equation that defines y. So this would be like -1 plus 1 and 0 plus 1 and 1 plus 1. So now instead of using x to find y, you use t to find both x and y. So why do we need parametric equations? Well, for the most part, we use parametric equations when we want to define two things in terms of something else. So like here's a picture of a woman throwing a ball. And let's say I wanted to know, well, where is the ball? What is the x location of the ball? In other words, the distance horizontally. And the y location of the ball, in other words, the height. But where are both of these things relative to t? In other words, after some period of time. So time is defining both how far the ball travels horizontally, but time is also defining how far up the ball is vertically. So let's look at a couple of examples. Sketch the curve created by, okay, and then here are your equations which define x and y, and notice they're both in terms of t. And then it gives you some interval over which to find the values of t. So I've taken all the values of t that they've given me for the interval here, and I've written all those values out here. So now one at a time, I'm going to be plugging all of these values of t in for x and y. So let's just plug the first one in. This would be -3 squared minus 1. So that would give me 8 for x. And this would give me -3/4 plus 2. So that would give me, let's see, 8/4 plus -3, that would give me 5/4 for y. So when t is at -3, the coordinates for x and y are 8 and 5/4. Right? And then I do it again. Now look at what happens when t is equal to -2. Plug in -2 for t. Right? You get 3 for x. Over here, if you plug in a -2, you get -1/2 plus 2, and you get 3/2. So when t is -2, you're now at the point 3/3. So we're going to continue to plug in t repeatedly for x and y so that we can get a bunch of ordered pairs for x and y. So you can pause the video now and go ahead and fill these in. But then the result, what's going to happen at the end, right, is that this is what our table is going to look like. Right, here's all my values of t right here from 3 to -3. And then these guys right here serve as my ordered pairs, 8 and 1 1/4, 3 and 1 1/2, 0 and 1 3/4, -1 2, 0 2 1/4, 3 2 1/2, and 8 2 3/4. So now I'm going to plot these points on my graph, right? This is the point I get when t is equal to -3, t is equal to -2, t is equal to -1. And what we notice is that the graph actually has a direction that it travels, right? Because these dots are happening as t is increasing. So that's what these arrows do right here. They show the direction or the orientation of the parametric curve. And it's important that we put these in because it's actually showing me not just a picture of what the motion looks like, but the direction of the motion as well. All right, so let's look at example 1b. Sketch the curve created by, and again, it's giving me equations for x and equations for y. And it's asking me to do it over the interval from -5 to 5. So I've taken these values for t. I've plugged them in over here. And one at a time, I'm going to be plugging them in to solve for x and y. So again, starting with -5, this would be 25/4 minus 1. And this would be -5/5 plus 2. So this ordered pair is going to end up being 21/4 and 1. Continuing to solve for x and y at each value of t yields the following table. So again, each one of these values of x and y is an ordered pair that I'm going to plot on my graph. So I'm going to start plotting these on my graph. Here's the first one, 5 1/4, 1. Here's the second one. Oops. 1 1/4, 1.4, right? And I continue to plot these points. And then I put in the arrows to indicate the orientation or the direction of movement for the curve. Going from -5, the arrows continue to travel toward +5. All right, so you're going to try this. This is guided practice example 1. Sketch the curve given by, here are the parametric equations for x and y, over the interval t goes from -3 to 3. So go ahead and make your table, plug in your values for t, plot your points, and put in your arrows, and then pause the video and check your work. Okay, so you should have found that D is the correct answer for this graph. All right, so a little bit of a different kind of a problem that you're going to do here. This time, instead of graphing, you're going to write in rectangular form. So rectangular form is the kind of graphs that you've always seen. It's going to be like f of x or y in terms of x. In other words, we're going to eliminate t or eliminate the parameter. So first, let's look at the parametric equation for y. That's this guy. We'll write it down. And then what we want to do is we want to solve for t. So I want to make this look like t equals, right? So in order to do that, I'm going to divide both sides by 2. And I get t equals y over 2. So now that I know that t equals y over 2, I'm going to substitute this value of t in here into the parametric equation for x. So I get x equals, and then again, instead of writing t, I'm going to write y over 2, and then plus 2. And then I'm going to solve this for y so that it's in the form of a function. So this is going to become x minus 2 equals y over 2. Multiply both sides by 2. I get 2x minus 4 equals y. And then if you want, 2x minus 4 equals f of x. Okay, so this is guided practice for example 2. Now it's your turn. See if you can eliminate the parameter and rewrite this in an f of x form so that you no longer have a parametric equation. So go ahead and pause the video, and then when you're ready, you can resume and check your answer. So you should have found that the correct answer here is A. Y equals x plus 4 quantity squared. All right, next example. So here are your parametric equations. Y equals 1 over 2t and x equals the square root of t plus 1. And they're in parametric form, and we want to write them in rectangular form. And then we'll talk about restrictions on the domain. So we're going to do the same kind of thing we did in example 2, where we're eliminating the parameter. So we'll start by writing down the parametric equation for x. And then we're going to solve this for t. So I get x squared equals t plus 1. And I get t equals x squared minus 1. So now I'm going to substitute that in for the expression for y. I get y equals 1 over 2. And then remember, now t is equal to x squared minus 1. And then solve for y. And this is already solved for y. So for the parametric equation x equals the square root of t plus 1, we just have to look at the domain of this guy. So remembering that this part has to be greater than or equal to 0. Right? So I would get t plus 1 is greater than or equal to 0 and t is greater than or equal to negative 1. And then for the equation that I solved for, this guy, I need to also evaluate the denominator and make sure the denominator is not equal to 0. Right? So 2 times x squared minus 1 would be 2 times x minus 1, x plus 1. So I'd want to make sure x was not equal to 1 or negative 1. So therefore the domain of the rectangular equation needs to be also restricted. Right? I need to make sure that x is greater than or equal to 0. And I need to make sure that x is not equal to 1. So I could graph these, right? And I would want to just double check them and make sure that I'm not graphing anything that's part of the restricted domain. So here's guided practice for example number 3. You're going to do the same thing. You're going to first take these two equations and eliminate the parameter. And then you're going to look at the restrictions for x and the restrictions for y and make sure you understand the restrictions on the domain. So try that now and then check your answer. So you should have found that the correct answer is B. And you'll notice that in B there's a restricted domain. The x has to be greater than negative 5. Okay, let's take a look at example 4. It says, write y equals 5 sine theta and x equals 3 cosine theta in rectangular form. So again, we're eliminating the parameter. This time the parameter, instead of being t, is theta, an angle. So we're going to start by taking our original equations and solving for theta. But we'll leave sine theta and cosine theta in it so that we can use them in our trigonometric identity. So we get y over 5 equals sine theta and x over 3 equals cosine theta. And then hopefully you remember this from chapter 5, our Pythagorean identity, that sine squared theta plus cosine squared theta equals 1. So now we're going to substitute in the two values that we just solved for. Y over 5 equals sine theta and x over 3 equals cosine theta. And we're going to plug these in here for cosine theta and sine theta. If you square these, you might recognize that this guy is the equation of an ellipse, right? So that's my a squared, right? That's how much I'm going to go up and down. That's my b squared. That's how much I'm going to go right and left. You may also notice that this ellipse is going to be centered at the origin, y minus 0 squared, x minus 0 squared. So we should be able to graph this guy. Right? Here's that 5 spaces up and down we talked about. And here are the 3 spaces right and left that we talked about. And then the arrows are the direction of theta as theta gets bigger, right? So starting right here with theta equal to 0, and then the arrows indicate that theta is increasing, right? Toward 90 degrees, there's 90, and then theta increases again toward 180, theta keeps increasing toward 270, and then theta keeps increasing toward 360 degrees as we go all the way around the ellipse. Okay, so guided practice, give it a try. Take the equations y equals 9 sine theta and x equals 5 cosine theta and see if you can put them in rectangular form and graph them. Give it a try, pause the video. When you're ready to check your work, resume. You should have found that the answer for this one is B. All right, last skill we're going to look at is using a parameter to take rectangular equations and rewrite them as parametric equations. So first they give us a parameter. They're going to define the parameter for you. So they gave it to us here as t equals x minus 1. The first thing we're going to do is solve it for x so that we can substitute it in our rectangular equation for x. That's going to put y in terms of t. So now y is in terms of t. And then this was the equation where x was in terms of t. It's really, really an easy process. So now we have two equations that are already in terms of t. And if we just pick a couple of values for t to plug in, then we can plot some points and graph. So let's take a look at the guided practice for example 5. Now you try. Use this parameter, t equals 2 minus x over 2, and see if you can take the rectangular equation y equals x squared plus 2 and turn it into two parametric equations, one for x and one for y, and then graph. Go ahead and pause the video, do the work, and then when you're ready to check your answer, then you can come back. Last one, give it a try. See if you can use the parameter they give you to take the rectangular equation and turn it into two parametric equations. When you're ready to check your answer, pause the video, unpause the video, and then come back and see if you got the correct answer. So you should have found the correct answer here was C.